All to the Spark Research YouTube channel. This is Dr. Veer Chandra, Assistant Professor in the Department of ECE. In this session, we are going to take the questions from this particular subject's network theory from the GATE 2025 series. Definitely Department of ECE. In this series, actually, we are now going to take the questions from this particular GATE 2025, right? So in this session, we are going to consider the questions only from the network theory, but in upcoming sessions, we will take the questions from the different subjects. Okay, let's go ahead. So before going ahead, here is the detail about the SRM IST, which is ranked on the 14th as per NIRF 2025, just above to the ATISM Dhanbad. So why are we talking about this course? So network theory is a core subject in the ECE, right? And questions, maybe the conceptual, actually, if you know the concept, then it will be very easy to solve the questions related to the network theorem. Particularly, questions may focus on the DC analysis or the AC analysis or transient, right? Weightage is almost 6 to 8 marks, so depending on the years. So here is the syllabus as per the IIT Guwahati is going to conduct your 2026 GATE. So I just got the syllabus from there only, so you can check it. Okay, so 2025 GATE has been conducted by your IIT Roorkee. So let's check the question now. So question number 20, what is this question? The question is let IC, IL and IR. So IC current which is passing through the capacitor, IL is similarly current which is passing through the inductor, and current passing through the resistor be a current flowing through the capacitor, inductor and resistor respectively, and so the AC admittances are given here. These values are AC admittances, for capacitor the admittances is J 0.25 and similarly like that. So we have to find out the values of the current which is passing through capacitor, inductor and resistance. Voltage is given here, right? So this is the question. So first question is that why admittances is given. So what is the difference in between admittances and reactance? So the reactance and resistance both are almost similar. Only difference is that the resistance is purely real part, real components of the resistance, but reactances is here along the which is occur in either capacitor or inductor, so it may have the complex number, right, or imaginary number. So and reactance and admittance are just reverse to each other, that is inversely proportional. Anyway, so we are going to find out the current which is passing through the capacitor, current which is passing through the inductor and current which is passing through the resistor. So now voltage is given, resistance is given, means admittance, and capacitance you have to, the current you have to find. So use the the simple things. We are going to use the Ohm's law, that is V is equal to IR, and we can find out. So that's a very simple. So as per the answer key provided by the iterate key, your answer will be the option A, that is IC is equal to these values IC, IL and IR. Okay, so let's see. Before going ahead, like in the question itself, it is given the voltage is like something voltage along with the angle. So let's see why is it so. So how will you correlate your angle with the magnitude? So anything like this is valid for voltage or a current both. Why? Your current, you can write the square root of 2 IRMS and the cos omega t plus phi. Phi is the angle, right? So what is the difference? Why are we writing it like so? Always current may not have the same phase, right? So that is why we are representing the phase, that is how much it is lagging or leading. So phase we can write along with the IRMS, that is the RMS magnitude. So similarly, if you wanted to write the phase in terms of the peak voltage, then here exactly you have to write the peak current. So how will you find the peak current? So just square root 2 into IRMS. As for example, here some more details. Im, that is the maximum current, you can find out. In our case, like square root of 2 into 1, actually it should be V of M, because voltage is given 1 and then angle is given 90 degree. So voltage is nothing, 1.414, that is the max peak voltage, right? Not the RMS. RMS is given and peak we have to find. Similarly, you can find the angle. Angle is also given 90. So your voltage can be written as square root of 2 cos of omega t plus 90. So here I have written as a current, but in question voltage is given, right? So let's talk about some more detail about the phasor diagram. Because in question itself it has given the your reactances is given in terms of the phase. So that is why let me talk about the phase so that it will be clear to for all of you. So why are we talking about this phasor diagram first? Because now if I'm considering the resistance, right? In that case, what will be the reactance? So it will be pure real part. But if we are considering the inductor or capacitor, then reactance maybe have the imaginary part. Why is it so? Because of the different phase. So in case of the inductor, you can see here your here it is cos and 90. So your current is actually lagging and your voltage is leading here, right? So since voltage is leading here, so now exactly like you are going to represent your reactances. So you can write XC is equal to omega into L, and we are also writing J into omega into L because it have the the voltage. If you are going to write, then you may have to write the aid the J because the voltage will leading. Similarly, here your capacity in case of the capacitance, you can see here now your current is starting from 0 and down, but voltage is already started, right? So you have to shift it left by 90 degree, then it will the overlap to each other. So your exactly here in this case also what is happening, your current and voltage both are not overlapping. There is again in this case also 90-degree difference in between the voltage and current. Here your in this case your voltage is lagging, and in this case it is leading, right? So this is the phasor diagram. So this is the just a concept. So if you will understand it conceptually, then it will be very easy to solve the questions for you. Some more details about the admittance that already has given in the question. So here your if it is capacitive, in that case your voltage will lead by the 90 degree and correspond with respect to the current. And here in case of the inductor, your voltage will lag with respect to the current, right? Current. So always you should remember the whenever the reactance you are writing, always it may have the two parts, real parts and imaginary part, right? So real part, and if there is no zero means it have the only not j components means it will have the only real part. But if it have the plus j means the your voltage will lead by the 90 degree, and if similarly if it will have the minus j means it is lagging by the minus 90 degree. So depending on the values of the reactance, values of the voltage or the current, you can identify, right, where the your voltage or current is lagging or leading. Okay, coming to the question now. So in our question, voltage is already it has given that it's a leading by 90 degree, and the RMS values is given one only, and then your reactance is for capacitor means XC is given that 0.25 J. So here your admittance that is given, like admittance is nothing, something like that 1 by R. So it is the it's a leading here, that is on the y-axis, and here it is I the admittance on the inductor, it is given that minus j, so it will be on the minus y axis, and for r it is pure real number, so it will be on the only purely x axis, right? So now let's find out. So voltage is given, that is 190-degree voltage. So you can also write the J into 1B. 1B is only and J because the voltage is on the y axis, right? Because the angle is 90-degree already given. Now what will be the current across the capacitor? So formula we can use it like I is equal to B into Y, because B is equal to I into R. So R and Y is just related to inversely proportional. So current will be V into Y. So B is what? B is given, that is J into 1, 1 into J, and Y is given for all individual components in our question itself. As for example, for capacitor, your Y is given J 0.25. So now voltage is J, that is 1J, into your admittance, that is Y is equal to J 0.25, multiply J into J, that is J square. So J square is equal to minus 1, so value will be minus 0.25 ampere. Similarly, you can multiply your voltage and admittance for inductor and your resistance, and we'll get the values like this. So these are the final values. In option A, if you will check, the IC is given 0.25 and angle is 180. So here it is C minus, and so why is it given that is 180? Because if it is like plus 90-degree, that it means it should have the J, and if it is have the minus, the minus J means, if it is 0 means on the real axis, and if it is having the minus j means minus y axis, and if it is minus means what, it is just reverse to the real. So here it will be, so cos 180, here it is minus 1, so that is why angle is 180. And for IL, here there is no minus or no j component, so exactly it will align on this real x axis, so it will be the 0-degree. Similarly for IR, that is the current which is passing through the resistor, it will be have the J. So since it is J means 0.2 and J means plus J means the plus 90-degree, right? So this is the answer. So as per answer key provided, your answer option A is correct. Okay, now let's take the another question. Another question is, consider a part of electrical network as shown below. Some node voltage and the current flowing through the 3 ohm resistor are indicated here, some indicated in this. Now they are asking to find out the voltage at the point X, right? So some network is given, you have to find out the voltage at this particular point. So this is being asked in this question, right? Nothing else. So as per answer key, your answer should be A, that is your 20 by 3. Okay, so let's see the question. So how can we solve? So first of all, don't get confused with the circuits. Your circuit is very simple. First, 9 voltage is given at this point, and so these actually we have to find out the voltage at this particular point. So first let's find out the voltage at this point. So 9, and use the amperes, use the Ohm's law, and so voltage minus how much voltage will drop across this resistor, right? So how will know that how much voltage will drop across this resistor? Since current is given, resistance is given, so find out the V is equal to IR. So total V into IR, that is 9 minus 3 into 1, actually here it should be 1 into, so VA should be equal to the 6 volt. So here it is 9 volt, but because of this resistor, 3 voltage has been dropped across this resistor. So now the values of the voltage is 6 volt here, right? So 6 voltage is at this point and 8 voltage is at this point. So definitely your current is flowing towards this direction. That is why your voltage is lesser at this point, right? So higher potential to lower potential. Now So current is flowing in this direction, then how we'll find out the voltage at this point? So first we will find out the current which is flowing in this circuit, that is in this way. So how we'll find? So potential difference divided by the total resistance, right? So we'll get it 2 by 3 ampere. Now simply the potential minus how much current is flowing. Current is flowing 2 by 3, and we'll multiply with this resistor, and we'll get the voltage at this point. So this is the technique to solve the problem. As per answer key, it should be your answer A option is correct. So let's see the some details. So here you can see in your question, the 9 voltage is given, and at this point we will first find out the voltage. So how we'll find out? So simply the voltage drop is by 3 voltage. So just take the difference, 9 minus 3. So voltage is 6, right? Now after getting the voltage at the point A, now we will find out the current which is passing through in this region, in this register. So to do so, the voltage is 2 volt and your total resistance is 3. So current will be the 2 volt divided by 3. So total current which is passing through the circuit is 2 by 3. Now finally we have to find the voltage at the point X. So how will find? Vx is equal to 8 volt, that is this, and minus how much voltage will drop across this resistor 2 ohm. So I, which is equal to 2 by 3, we have already got, and into the 2. So that will be the final answer. So you will get the 20 by 3. So this is the final answer. Okay, now let's take one more question. So in this question, the Z parameter matrix of two-port network relates the port voltages and port currents like in this manner. So this is also called the Z parameter matrix, and of the network it's given. Now you have to find out the Z parameter matrix, right? Means Z11, Z12, Z21 and Z22 we have to find out for this Z parameter network matrix, right? So as per answer key, your answer A is correct. That is, this values is correct, right? So let's find out. First of all, if you have the questions like this, then write, the either first you can write down your equations like V1 is equal to Z11 I1 plus Z12 I2, and V2 will be equal to the Z21 I1 plus Z22 and I2. How can you write these type of equations? You can check your question only. So this is very simple technique to write. Now, from your matrix, question matrix only you can write. Now, see here the two things, right? Here two things are there, I1 and I2. So if you will make I2 is equal to 0, then what will happen? This term will vanishes and we can find out the value of Z11, right? Z11 will be equal to how much? V1 by I1. So we are going to use that technique only. So make it I2 is equal to 0. So just this part will vanishes, and so v1 z11 will be equal to v1 by i1, right? So how can we find? So in this manner, uh, v1 how will z11 yeah, so how will find? So total it will be just it will be neglected because I2 is 0, and in that case your you can look like this will be also open. So your total resistance will be 2 plus this 2 plus 2 and 2 this resistance, and the combination of these two are in parallel, right? So this is parallel with the combination of these two, right? So 2 parallel with 2 plus 2, and so input resistance looks like from here it will be your 2 plus 2 into 2 divided by 2 plus 4. So finally it will be 10 by 3. So this is the value of Z11, that is V1 by I1, right? So it will be equal to the resistance which will looks like from this point. So also, since this is symmetric one, always your Z parameter will be symmetric. So Z11 equal to 10 by 3. Similarly, Z22 will also be equal to the 10 by 3. So now we will find out the another parameter, that is Z21 or Z12. So since we have already set it as I2 is equal to 0. So now from equation number second, I2 is equal to 0, and so I1 V2 divided by I1 equal to Z21. So just write this equation, Z21 equal to V2 by I1. So V2 we are going to find out the voltage across this terminal, and the current here already we have the suppose I1. So we'll find out the voltage and then divide by I1, then we'll get the value of Z of 21. And similarly Z12 will be equal, Z12 and Z21 both will be equal, right? So let's find out the Z21. How we'll find out? Using this equation V2 by I1. So to do so, first find out the current in this. So how will find out current in this? So your I dash, suppose I dash will be your I1 into this is your 2 and divided by your 2 and 2 4. So 2 plus 2 4. So I dash will be your I1 by 3, and voltage across this, that is 2 ohm. So this will be current which is passing through this region, and then 2, so it is 2 by 3. So your Z21 equal to the 2 by 3. So since your Z11 Z22 both are same, so 10 by 3 10 by 3, and Z12 and Z21 is same, so 2 by 3. So this is the final answer. So thank you for joining the session. If you have any doubt, if you have any problem, please drop your comments.